Here in the Dagpunar textbook, we are in Appendix 8.2 and looking at reliability inference. In this certain case, we're looking at the probability of failure for a component at a certain number of hours. In particular, we are looking at engine failure for an airplane. And what we'll be using for this is a Weibull distribution. So effectively we'll be solving for alpha and beta values so that we can fit a model according to the data that we have and predict the probability of failure at a certain amount of hours. And moving into MATLAB, we can see that we have our data input of historical data, as well as a number of iterations that we're going to run, and some initial alpha and beta values. We will be running through and using log likelihood to continuously loop through and solve for an alpha and beta that would give us a graph that best represents the data that we have put in. And running this, we can see in a histogram our actual data on the right, where we have the failures in thousands and scaled down here, divided by 1,000 for the hours until failure. We can see the general trend is very similar, as is the scaling of the graph. And on the left we have a PDF graph, so the probability of that exact event going on, which initially is spiked upwards very much and then slowly goes down as we continue through. And the second graph here, we have a cumulative density function graph where we have the 1 minus the CDF here, and we can see that there is a decrease in probability as we're going down, and eventually it reaches 1, and the probability of it reaching 10 hours is very slim. And from the output we can see the probability that the engine will last longer than 1,000, 2,000, or 3,000 hours in this order, where the probability of reaching 3,000 hours is about 24%, which we can see right here in our 1 minus CDF graph. So thank you for watching on how to use this in MATLAB, and we'll see you next time.